Hi, good morning, everybody. My name is Harsh Mehta. I'm the recruiting specialist at the College of Engineering. We'd like to thank you and welcoming to our first session for our wonderful College of Engineering Wonder Week. Depending where you are, it's probably morning, afternoon, or evening. So you're in for a 45-minute session. I will go over some admission slides. Then, of course, I will pass it on to Dr. Ferrero, who will go over his program, and then we'll wrap it up with some more admissions-related slides, and then of course open up for Q&A. This session, like I said, is recorded and you will receive a follow-up email regarding this session. But some housekeeping rules, of course, is the bottom of your screen. There is a Q&A feature. Please use that Q&A feature to access any questions you have specifically for your program. This is definitely a program-specific session, so this is a great opportunity to ask specific programs questions. If you have any admissions-related questions, those unfortunately will not be answered as that requires more detailed, and then that is something that you want to email us in our admissions, and our team will work with you on that. So just some covering rules of just Northeastern and what great university we are. We are a top ranked R1 research institution, and we really strive on experiential learning. We are continuously celebrating our 115 years of co-op, so definitely we are #1 ranked in co-op and internships. And a fun fact is that the College of Engineering was the first college within Northeastern to start co-op. So we're really excited and happy to see how successful it has been. Within Northeastern, there's 10 colleges and schools, and we have over 50,000 students. So although we are a massive network, you will also see where we are located. We have everything from MS to bachelor's all the way to PhD. And then, of course, we have something that's massive within Northeastern is our global campus network. So this is just a little glimpse of where Northeastern is and where we continue to aspire. The program that you're looking for is in our Boston campus. And of course, I'm sure it's going to be expanding to other locations as well. So this is just a glimpse of where we are at the current moment. And then, of course, what is the College of Engineering? So we make up about 1/3 of the university. We are a very popular college, and I think our programs speak for themselves. We also are top ranked 38 for best graduate engineering school, as well as best 37 for best engineering for undergraduate school. So these are just some fun facts of what we have. And then, of course, is what is within the College of Engineering. So we have 6 colleges or 6 disciplinary. So we go everything from bioengineering all the way down to multidisciplinary graduate engineering. So there's definitely everything for everyone. So definitely let your friends know that there are programs for them at Northeastern. Following that, what is our mission? So COE, this is something that our dean is very strives for, and is an academic institution. Our main product is people. Our success is based on the quantity and quality of the people we produce. So that looks like good engineers solve problems, great engineers solve important problems, and transformative engineer discover and solve important problems. And that is something that the university is super informative about and super proudful, and we continue to see it in our students and as well as in our faculty. And that is something that I would like to pass on to Dr. Hart.
Okay, thank you for the introduction. So my name is Rolando Herrero. I run 2 programs. I run the telecommunication program in Boston, and I also run the cyber physical systems in Boston and Toronto. So this presentation is about all those 3 programs, Boston telecommunications, cyber physical systems in Boston, and cyber physical systems in Toronto. So I'll try to do my best to put as much information as I can in the limited time I have. As usual, any questions you have, you can reach me at that email. I typically respond within 24 hours. I always respond, even if it is to tell you I don't know what the answer is. And I try to do it within 24 hours. If you do not hear from me for a day or so, just resend the email because I'll get back to you. Okay. Next. Let's start talking about telecommunications. So we have these telecommunication programs that is, it dates to the end of the 1990s when we had the internet revolution. So there was a huge need for integration to internet protocols, internet technologies. Back then, what started with data networks it has moved through the years and through the last decades into every single aspect of communication that exists out there. So now, since you woke up in the morning, since you go to bed, you have used already like hundreds of different telecommunication sessions, and most likely run some sort of IoT, Internet of IoT communication mechanism, right? And I'll talk about IoT in a little while. But so in that context, these telecommunication programs is a program that has been highly successful for many, many years. We have had around 1,000 graduates since 2004. It's one of the 2 telecom programs that are recognized in the United States. And a lot of other graduates go to work in companies like Verizon, Nokia, Amazon, Google, Facebook, and many other startups, right? Corporations, but also startups. Again, this is a Boston only, and we have one of the highest interns and co-op placements in the whole College of Engineering. So again, this is purely a Boston located program. Very, very, very industry oriented. Next. So as I said, right, so since the late 90s till these days and in the future, the big revolution has been the internet. So the internet has started like a data network protocol developed in the 1970s to enable communications between universities and agencies of the US government, to now that is something that is used for everything, right? Anything you do goes over internet protocols. So the main focus of this program is those internet protocols and how those internet protocols can be used basically to support all types of different mechanisms of communications. That also implies what we call the layer architecture, in which you have different layers, in which the internet protocol is one of those layers, but there are many layers that are related to that internet protocol. So our main focus is on that. So we use telecommunications for everything. Everything is internet based, right? Again, IoT, data center, wireless communications, everything one way or another one relies on internet. So networking and telecom are very, very exciting areas, a lot of hot areas, anything ranging from virtualization, software-defined networks, IoT, 5G, up and coming 6G technologies, not really fully standardized yet, cloud, edge computing, automation. This is the kind of stuff you do when you work in DevOps. Because again, every company now has some sort of IT department in which you're going to have to deal with the networking and communications. But beyond that, how do you send data from between cities, right? All these transmission networks, a lot of stuff is optical. Even those optical networks have migrated to internet for basic communication. And very important, security, right? Security is paramount these days and is at every single level. So typically telecom and networking graduates get great jobs and pretty good salaries when compared to other engineering branches. Next. The program is unique, is focused on the industry. This is something very important to take into account. If your goal is to do research, to write mathematical models, to rather than build the communication systems and understand how IoT protocols and standardization goes, you're more interested in doing the mathematical models that those protocols and those technologies are based upon, then you want to go for a PhD type of degree, something like electrical engineering, a master's in electrical engineering and communications, or something along those lines. If you're more interested in going into the industry and actually work with, rather than doing the theoretical development of those systems, but actually the practical development, this is probably the career for you. It is one of the top networking programs in the US, as I said, and the location is in Boston, which basically is central to faculty, not only from Northeastern, but from all other places. You have local co-ops, but also US co-ops too. This, in many cases, lead to full-time jobs. The program content is basically attuned to what the industry needs. We have an industry board that we just are building right now with companies in the area of telecommunications and cyber-physical systems, and we basically interact with them to know what they need and what they think the job market will look like. Again, courses cover pretty much every single technology out there that you may be interested in. There is a lot of flexibility with the choice of electives. There is a great trend to softwareization. So even as a, your traditional telecoms networking student 20 years ago didn't need to write code. Now you have to. Pretty much coding is a must in pretty much every single branch of engineering, and telecom is not an exception. So that is very software centric. And most of the classes, if not all, they're very project-oriented courses where hands-on learning is paramount, right? This leads, because you have so much hands-on experience, and you stay away from mathematical theory and on fundamental theorems and more into the practical side. This leads to really good job placement, right? So if you're a company and you need somebody to implement a specific protocol, right, on software, you probably want somebody that has experience writing code, not somebody that knows how to model mathematical and communication systems. So that's basically what this program can get you. Okay, next. So for the requirement we have, and this is the other good thing. So you only have to take 8 classes in 2 years. This gives you a lot of free time, although the classes are demanding and you have a lot of stuff that needs to be done, a lot of hands-on stuff. Basically, you need to take 2 classes per semester. That give you a lot of free time to do other things, anything from certifications to volunteering for projects here, volunteering for clubs, and stuff I'm going to mention shortly. Is again 8 classes. Our goal is to get you ready for the industry. Therefore, unless you want, there is no thesis or project requirement. We do offer that if you're interested. If you want to do a thesis or you want to have a capstone project, we do offer that, but it's not mandatory. It's really at the end of the day, it's up to you. You have electives basically from our MGen department. Which this is hundreds of classes that you can take in anything ranging from software engineering to data management and things along those lines. In addition, under special circumstances, if you can prove it that is something that is relevant to you, you can take classes in electrical engineering and computer science too. But again, you need to make a point, right? It's not, we prefer if you take classes within our department, but if you say, hey, in electrical engineering, they have this particular class on this particular technology, you're really interested, you can take it. In general, the program we offer under MGen has pretty much everything you need anyway to begin with. The same goes for business electives. If you're really interested in particular business electives, you can take them. You can make a point why you want to take it. All other classes within our department, you can take them without any requirements, and you can register directly. For the other ones, you need a particular process called petition. And once a petition is approved, you can take those classes. Next. So for required courses, main classes focus on different aspects of the internet. Data networking is key. You need to understand the layer architecture. So the main focus is on the ATF layer architecture. That's Tele 5330. Then you have a class on telecom infrastructure, basically how do we get telecommunications to actually work from a perspective of wireless and wireline communications. And then you have another one that is another core class, which is specific on the internet protocols. It's an offshoot of 5330, but a little more specific on the standardization and the architecture of the protocols. Again, this is where you learn, the RFCs, how to read the protocol, how to interpret the protocols and be able to use them and, build systems with them. Next. As you see, there is a variety of classes. Classes typically in the telecom and cyber-physical systems domain, it starts with the suffix tele. And as you can see, a lot of classes covering a lot of areas. We also have classes in other areas within our department, like cryptocurrencies and smart contracts, that basically cover some of the stuff associated with information systems and software engineering. So but still you can take it and it comes like any other regular class. Next. In addition, software is super important. As I said, a lot of emphasis on software, anything from learning how to use operating systems, in particular Linux, which is used pretty much in anything these days, to the development of tools for automation, like if you're interested in DevOps, to the development of parallel computing, right? Next. So that's from the telecom perspective. Keep in mind, I haven't gone through the details of every single class because I could spend literally hours doing that. And I don't think that's the purpose of this. I mean, I just want to give you a quick overview so you understand the structure of the program. So you can go to what we call the catalog for 24-25 and see the specific details of all of the classes. But essentially, any class that starts with the suffix tele, info, CYSE, or DAMGR, you can take any class of those within the telecom program. So you're not restricted to tele classes. You can take any one. The only thing you are basically have to take the core classes, right? You need to comply with the core classes. Now, telecom is very, very important, but it's a very, very well-established area of study, right? And it's something that is very, very, well known. Now, there is a new concept, which is the concept of the cyber physical systems. So physical systems have been around for a while, but in the last few years, in the last 10 years, they have gotten a special impulse because of we're going through a process of deglobalization, depopulation. Those two things are happening right now in the world. And basically that leads us to start building systems that can be autonomous. I'm not talking about robots, right? So robots is just a component of the cyber physical system. I'm talking about the full cyber physical system where you have devices, regardless of whether they're robots or they're something else, devices that interact with the environment. They do that by means of sensing and actuation. Then you have applications that provide intelligence. This is done through AI. And then in between, you have telecommunication technologies known as IoT protocols that enable those applications to interact with those devices. That compound, right, is the cyber physical system. We have a physical part with physical world in which we interact with environment through sensing and actuation. We have a virtual world, a cyber world, in which we provide this intelligence, right? And this was not possible 10 years ago, but now it is for many, many reasons. Stuff like cheaper electronics, AI mechanisms that you didn't have enough computational capabilities to use, although they were known, and protocols that are lightweight, they're designed to support that connectivity. The reason you have this architecture is because you want to have autonomous, if you want to put it that way, sensors and actuators, robots that they are wireless. They talk to gateways. The gateways to talk to applications that they understand the whole ecosystem, right? So you want to have centralized intelligence with devices that actually provides that interface to the environment, right? So this is what a cyber physical system is, and it's something key in the global context, in particular to the United States, where due to current conditions and future conditions, there is a big push to industrialization, reindustrialization, doubling the manufacturing capacity in 10 years. And that will require to design cyber physical systems to do it, right? Just to start. Next. So the IoT is that glue that connects the cyber and the physical part, right? And the way we do it, like we do everything communications these days, is with internet protocols. So rather than using a standard internet protocol, we use a special flavor of internet protocol, which are called the Internet of Things protocols, which are fine-tuned to enable that communication between devices and applications, which is not the same as the communications between humans and humans. That's why we have special protocols. Next. So now, because we have that need, there is geopolitical changes that force these needs. There is depopulation, fewer people. We need to have better monitoring of things. So it doesn't affect just manufacturing, but it affects other things like smart cities, where you want cities that they are going to monitor themselves. You want connected health, in which you interact as much as possible with machines to get a diagnosis. You want automated homes, home automation. You have vehicle to infrastructure communication to support autonomous driving, and so on. All those things are all coming together. They are all cyber-physical systems. And the reason they exist is because we now have the technologies to do it. We did not have that before. We wanted to do it, but we didn't have the technologies. Next. So this is the solution. So the solution is your smart devices, your IoT networks, and your smart applications. By the way, this is a drawing that is coming from 2010 ETSI. ETSI is the European Standards Institute that described at that time what they call an M2M system solution, a machine-to-machine system solution. This has evolved, and now it's the fundamental of cyber-physical systems. So those three areas, right, devices, applications, and networks, is what our programs focus on. Next. So with that, we have three tracks. We have a track for smart devices, a track focused on IoT networks. If you're more into the telecom stuff, the IoT networks is probably the track for you. And then we have a smart apps track, which leads with the development of essentially AI and machine learning applications. This overlaps in content, and because there is a lot of options to take classes in our software engineering and information systems program. Next. So why Northeastern for cyber systems? Because again, we have two options, Boston and Toronto. Boston is ranked 4 worldwide for cyber physical systems. Again, we're close to MIT, Harvard. We have our own mass robotics incubator in the state that actually focuses on robotics and cyber physical systems. In Toronto, you have Toronto, which in Canada, you have Toronto, which is the IoT center for Canada, and a lot of companies like Cisco. We basically have a lot of interaction with companies. We do have in Boston the IoT Connect Club. We also have memberships of some standardization bodies, and we opened this fall a lab in Boston. We are planning to open a similar lab in Toronto at some point. Right now we don't have a date for that, but we do have a lab in Boston, which is used to support both telecom and cyber physical systems, and basically enables you to support classes, to support summer R&D that we are doing, depending on the case. Right now, it's mostly volunteer basis, and support industry events. We're using that in the lab. I'll talk about that shortly. And again, as a telecom program, you can take cyber physical system specific classes, but also classes in other programs under MGen. Basically, have no restrictions. You're not going to need to have any special registration to take those classes. And we basically have intensive and very important co-op program where this is very important these days. You see a lot of competitions and jobs in the AI domain. So if you want to write, if you're going to find a job in machine learning and AI is very, very complicated, right? Because there's a lot of competition in that area. IoT, not that difficult, right? In fact, if you know both AI and IoT, that give you a very competitive advantage with respect to people that should know only AI. But the other highly hot competitive area these days is device development. That's an area in which, because of the skills you need, are slightly different to the software skills that you have on application development, on AI, on cloud. It's very difficult to find people, right? So that's an area that is very, very, very demanded. There's a lot of demand these days. So this program covers all. You basically, that leads at a pretty good array of internships that are available. Next. So this is the lab opened this fall. We support teleclasses related to cyber physical systems. Basically, we support applied research in search of external funding. That means essentially funding from agencies, US agencies. Again, I mentioned the need for cyber physical systems going forward. So a lot of funding. The government is putting a lot of money in that area, so we are trying to address some of the funding. Also, we support industry events and hackathons in this lab. Next. So, for example, we are working right now on a leak detection in fracking project. We're working on a cognitive digital twins for Industry XO migration. We're working on fall detection with wearables. Also, we're working on a sepsis detection medical emergency system, which is part of a broader research program that started in Oakland, California. So that's some of those things. Right now, the way it works is we have students volunteering with the, if with the idea that if we get funding, that potentially may go to them, right? Again, this is a brand new lab, so we are just starting with this. Keep that in mind, but that's our goal. We're also supporting hackathons. We supported and finished just a week ago the Silicon Labs Matter Challenge. We have a few submissions from this lab. We're currently working on the Raspberry Pi 2350 challenge, which has a deadline of December 31st. And next spring, we're going to be working on the Miters Capture the Flag challenge, which is going to spread most of Q1 of 25. So if you're, for whatever reason, you're coming here in the spring, let me know. And you're starting with this program in the spring and you're interested in that challenge, you can probably join. Next. Some highlights of the Cyber Physical System program. It is, again, follows the same modality as telecom, eight classes spread over 2 years, with typically a co-op. Same thing is valid for telecom, with a co-op in between that basically give you, enough time to do other stuff like volunteering for R&D, volunteering for hackathons, participating in events and so on, participating in clubs. We basically have a lot of stuff associated with embedded systems. Hardware is provided by means of our lab. So right now we have a lab. So you come to the lab in whatever time you have assigned, and you basically have a huge array of hardware you can use. Anything from scopes and power supplies to pretty much most of the well-known smart processors out there. Anything like a Raspberry Pi, Arduinos, ESP32s, and so on. The College of Engineering has a major strength in network, wireless communications, data science and analytics, software engineering, and databases that can be used to enhance your knowledge in this class, in this program. So you have that can be used also for your selection of courses. There is pretty good flexibility. Most courses are project oriented. Again, the same thing applies here, right? So this is not your electrical engineering IoT program where you're going to learn, the mathematical fundamentals of IoT communications, right? So here you are learning about the protocols, knowing how to implement them, and implementing them and using them, right? So that's one big difference with respect to what you can get in electrical engineering, for example. So we're a lot more practical, more industry oriented. Therefore, our focus is on co-ops and on the industry. Next. So degree requirements, as I said, 8 classes, 2 years, 4 cores. My recommendations is basically to take fundamentals of IoT and machine learning in the first semester. This is machine learning for IoT. It's not your usual machine learning, so you may want to take it the first semester. Then if you are interested, depending on what area you're interested, you can choose whether you want to focus on devices, you want to focus more in the communication side, you want to continue focusing on AI. We basically have all kinds of options. So you take essentially 2 core classes, actually 4 core classes and 4 elective classes. So that's a typo, by the way, there. It says at least 3 other electives. It should be 4 other electives. And note that in Toronto, you have a requirement for a capstone project, which has to be done the last semester. That's typically a project in which you implement an end-to-end cyber physical system, right? So if you are in your last semester in Toronto, you're going to end up building end-to-end cyber physical system. And my recommendation always is to take the device development class Tele 6550 if you're in Toronto and you're interested in building a real cyber physical system, because then you already have your machine learning knowledge, you have your IoT knowledge. That last component is that class, right? Then you can build your end-to-end system. Next. So there are many electives, anything focusing on devices, applications, and communications. Keep in mind, these are based on location. So I'm showing you what is offered everywhere. but some of them may not be offered in places like Toronto, right? So be aware of that. Some of them may not be offered in every semester. So there is some, this is what, at some point in the year, you will find either in Boston or Toronto, either in the fall or the spring. That this doesn't mean they're all offered all the time in all places. Next. Also communications, more stuff about applications. So wide range, you only need to take 8 classes, right? So you have a lot more stuff to choose from than what you can take. So next. And that's taking into account, I'm not even considering electrical engineering, computer science that may be relevant to you. A lot of faculty that work on both academia and industry, that's important. You interact with people that are currently working in companies. They may end up being your colleagues later on. Next. Our also faculty have written state-of-the-art books, use not only these programs, both telecom and IoT and artificial systems, but used by programs all over the world. Next. We have our co-ops are characterized by, letting the way to students to interact with companies. But in order to do that, we need to make sure what the industry needs. And in order to do that, one of the things we have developed is our industry board. Our industry board combines corporations like Silicon Valley, Schneider Electric, Convergent, and startups, and nonprofits like UMass Robotics and University of Cincinnati, which is a main advisor to the National Science Foundation on artificial systems program development. So all of those are part of our, among other companies that you can see there, are part of our industry board, which has started this semester. Next. So the admission criteria is GPA equivalence of 3.040 in undergrad degree from a reputable university. But again, this will also depend on your life experience. So, I have seen students that, for example, they have had a, biology degree, right? But after they graduated as an undergrad in biology, they went to the industry. They developed software development skills. They started writing code. They somehow got involved with communications. So they have some relevant industry experience that in many cases will enable us to bypass some of these requirements, right? So that's very important. So if you don't have, a super STEM technical degree in your undergrad, but you do have the experience because you have gotten it later on, that still doesn't make you, unqualified for this degree, right? So it is basically given, carefully given personal, on a one-on-one basis, the applications are given attention, right? So in other words, we look at the applications and we just read everything there. So that's why it's important to detail your industry experience if you have any. So that's why. So those are ideally what we want, but if you have industry experience, that may override those other requirements. GRE is not mandatory. You do have to have an undergrad degree. That's for sure. I mean, that's, if you don't have an undergrad degree, don't even try. Ideally, also you want to have some exposure to programming, and they could be even you're interested in building devices, right? Which is a very hot area, as I said, and requires very specific skills. They're not the same software skills, the same programming languages that you use to develop AI applications and cloud applications. And you still want to have some software experience if you never had done any. And typically that translates to Python, right? So you want to have, before coming here, even if you haven't done it, get up to speed with Python, and ideally object-oriented programming, so you can skip one of the, if in particular in artificial systems, if you can skip one of those requirements, which is, core classes that you can take, which is object-oriented programming. If you're telecom, Python should do it for you, right? So I will definitely focus on that. Okay, next. Industry co-op, basically the way it works, we have a whole department here. What they do is they help you find that internship you can do after you finish the first year at Northeastern in the College of Engineering. Typically, so you understand from a funding perspective, this is an industry-oriented program. So, and in general, you're not going to find master's programs that are going to provide funding. It's rare, but also because of the competition, right? There is a lot of master students. But with our program, right? So once you start the first semester, if you do well in the classes you're doing, there is a big chance you're going to get a TA, a teaching assistantship, the next semester. After that second semester you're here, then you're ready to go into the industry co-op. Industry co-ops go anywhere between 4, 6, or 8 months maximum. We have a department that will actually help you find one, but doesn't mean they're going to do the job for you. So if you don't basically get up to speed and you have the right skills and the right and you're not competitive enough, probably you won't get a co-op. So you need to be aware that you do your job too. Again, this is typically between 4, 6, and 8 months. Our co-ops are fairly competitive compared to other programs out here because we are in a niche, right? Again, we do AI, but our AI is in the context of artificial systems. We do telecommunications, which is also a niche by itself. We do IoT protocols, which is a niche. And device development, which is not a niche, is something that is actually needed by a lot of companies, but there is not a lot of people that can do it because you need hardware, and not a lot of programs has the hardware to support you. And also the software skills are not the same, as I mentioned again. In either case, for your industry co-op, you need to take a 1 credit class, typically the first semester, that is called ENCP 6000, Career Management for Engineers. This class gets you up to speed with everything you need to know if you want to, if you want to go for this co-op. This is typically useful, typically done by international students. If you are part-time or local, typically you don't care too much about internships, and you probably don't need this. Yeah, you will need it anyways. You're gonna go for an internship, regardless of what your background is. But what I'm saying is, a lot of internationals already, domestic students, they already work because they're part timers. But if you are, international, full time international, and you want to go for an internship, you need to take this class, right? Once you finish with your co-op, you come back, finish whatever classes you have to have. You take in the last semester your last class or couple of classes that you may have pending. One of the classes has to be on ground, right? Which brings me to another topic that I mentioned. Many of these classes, or at least until very recently, offer the possibility of on ground. Some of them offer online capabilities. We're phasing that out. Starting in the spring, mostly all classes are going to be on ground, regardless of where you are. That's a college-wide decision, which means you're going to have to be present in classes. So this restriction of on-ground class, at least one on-ground class, pretty much doesn't exist anymore because we won't be offering online classes anyway. Next. So this is typically the timeline for your co-op. You see, you can start at certain months and finish at certain months. Some of them line up very well. Actually, all of them line up very well with, the beginning of a particular term. And this is done on purpose. Next. These are some of the companies our graduates have gone to work for. Okay. Next. To go to co-op, there are some restrictions. You have to have a pretty decent GPA, which makes you, at the end of the day, that's important regardless, because typically if you don't have a good GPA, that means you probably don't have the right skills anyway, right? So that goes, if you have the right skills for an internship, you most likely will have a good GPA. So GPA has to be 3.2 or above. You should have completed the ENCP 6000 with a passing grade. You should have completed 16 academic credits. Already, that's essentially a whole year, right? 4 classes. If you are in US, there are certain legalities which I'm not going to mention. The same thing for Toronto, so I'm not going to go through that. Next. We have ambassadors. We have an ambassador in Toronto, which is Amar. He's online right now. The ambassadors, and that's their email, they will provide you with information about what to expect and provide recommendations about your success in the program. Next. I think that's it, right?
Yep, perfect. Thank you so much. So I'm just going to quickly go back a slide regarding the
Yeah, I
ambassadors.
apologize. I realized
No,
there was
it's
no
okay. I
Wi-Fi.
appreciate it.
And
I would just tell students that have tons of questions regarding some programs and stuff, definitely scan the QR code. And we do have an ambassador that is in our chat that I'm gonna allow him to introduce himself.
Hey, hi everyone. This is Amir. I'm in the second year of cyber physics systems here in Toronto. If you have any questions, please shoot out an email to us and we'll just revert back to you within 1 to 2 days.
Perfect. Thank you. So just to wrap up really quickly, so these are some of the next steps that we would like to go over with you all. So if you already have received your decision, which I feel like some of you already have typed in, this is our roadmap that you want to definitely do regarding your next steps. Of course, is paying your enrollment fee, and then of course you will follow your track within your application portal. If you are an international student, you do want to be mindful and apply for your I-20. We do understand the process is lengthy and just take some time for the university to process it. So definitely don't wait to the very last minute. I also know there's a lot of students typing in regarding that they're very interested and they want to apply to the university. So yes, there are applications are still open. This is what our application looks like. So for any international students for the spring, however, the application has passed. But if you are a domestic student, you still have about close to 2.5 weeks to still submit an application. For the fall, the MS priority deadline is January 15th, and then everything else falls in their June and July. But definitely don't wait to the very last minute to submit your application. The application requirements, of course, are 2 letters of recommendation, unofficial transcripts, statement of purpose, your resume, and like we stated, GREs are optional. And then if you are an international student, we accept 3 English proficiency exams. So they could be either IELTS, TOEFL, or Duolingo. And for the students that have been asking for a fee waiver code, that is the fee waiver you would use, which is apply COE 2025. It is case sensitive, so please be mindful for when you use in that fee waiver code. And if you are a new applicant, the fee waiver code will only work. So if you're already a student that has submitted an application, you unfortunately cannot use that fee waiver code as the system will not allow it. So just remember, everyone, it is case sensitive, and that is a fee waiver code you would use. Following that, we're around the clock and we are available, just like how our ambassador said. They respond really quickly, and so does our admissions team. So if you have specific admissions related questions, you will email us at coe-gradadmissions@northeastern.edu. And then for the ambassadors, it will be coe-ambassadors@northeastern.edu. We are on all social media platforms, so definitely connect with us. A lot of you have asked if this video or this slide deck will be shared. Yes, the slide deck won't be shared. The video will be, and it will be on our YouTube page, which you also will receive a follow-up email in regards to that. So without that, I'm going to open up for Q&A. I know I've been answering some, and I just saw Dr. Herrero answer some too, but definitely please type in any questions you have. We have about 5 more minutes of this session. And I do want to answer, I know we have a lot of specific scholarship questions. So the university does review all students that do apply for a dean scholarship. But if you visit our scholarship page, there are a lot of resources available there as well in regards to scholarship by external companies and external parties that you could apply for, even if you're an international student. That's a great question. Can a COE ambassador help in reviewing SOPs and personal statement for feedback? They can't review it per se, but you could definitely connect with them and ask them for some advice on how you could, on what you should include and what you should add into your SOP or personal statement. But I'm gonna let Amir talk about what did he include in his personal statement or his SOP.
Yeah, so we usually do not give any feedback for the statements for your visa interviews and everything. But while applying for your program per se, we do like say like what we look for and like how you could improve your profile overall.
So Amir, what made you apply to Northeastern University for this specific program?
First of all, like the whole diversity of the great professors we have here at Northeastern, and like we can apply for like any electives that I can take if it's offered even in like Boston, Seattle, Vancouver, anywhere, and the great city of Toronto. It's beautiful over here.
Perfect, thank you. Sweet. So it doesn't seem like we're getting any questions. So I like to thank you all for that piece. Great question regarding English proficiency exam. So no, if you are a student that has completed your undergraduate degree already in the United States, you do not need to submit an additional English proficiency exam since your education is already from the States. So for students that are are completing their degrees in the spring of 2025, you would apply for fall of 2025. So you would still be submitting your application now. We don't require official transcripts until later on in the process. So you could submit your unofficial transcripts, and in the application, you could specify that you are your expected graduation date. IELTS will be I'm sorry, IELTS have to be official from the IELTS exam board. We don't take self-reported IELTS scores. And for students that have already been admitted, you would want to start your next steps by starting your I-20 process. So I'd like to thank you all for joining us.